Okay. Good morning, everyone. Good morning.
Good morning, sir.
Good morning, sir. Thank you. Sorry for the delay due to some network issue. Is it screen is visible to everyone?
Yes, sir. Yes, sir. It's visible, sir.
So welcome all for today's session. So myself, Girish. So I'll be taking the session on the LAN chain. So first thing is what is LAN chain? So LAN chain, it is a framework designed to specify the creation of applications with large language models. So now when you say what is large language models, that is LLM. So LLM, large language model, is a type of AI program that can be that can recognize and generate text among the other text. Okay, so that is the LLM. So now, so in this, this is the agenda what I'll be covering for today's session. So the problems with LLMs. So why LAN chain and what is LAN chain? The components of LAN chain, the working of LAN chain, applications, setting up the LAN chain, the interacting with LLMs using LAN chain, so retrieving generated text and responses, and the case studies. So now, as I told that LLM stands for large language model, and it is a type of AI program that can recognize and generate text among the other tasks. So LLMs are trained on large sets of data, hence the name large. So now I'm is it screen is visible? The screens are moving.
Yes, sir. Yes, sir. It's moving, sir. It's visible.
Okay. So sorry for the inconvenience. So now this is the agenda. So that will be covering in this session the problems with LLMs, why a LAN chain, what is LAN chain, the components of LAN chain, working of LAN chain, application, setting up the LAN chain, interacting with LLM using a LAN chain, retrieving generated text responses, and the case studies of the LAN chain. So as I was telling about LLM, so LLM stands for large language model, and it is a type of AI program that can recognize and generate text among the other text. And LLMs are trained on large sets of data, hence the name it is large. And there are drawbacks in LLMs. So LLMs lack language of the recent events, so including the powerful models like GPT-4, and it was able to only useful for till GPT 3.5. So LLM pursue the world as static based on the information available during the training. So this because the problematic for the use cases that requires up-to-date information or the specific data sets. So now the LLMs are it is very much it is a static, and it is based on the information available during the training itself. So training LLM for every new information added is not only the inefficient, but also it is very much impossible. So imagine if you have a confidential medical data that you want to use with LLM. So that was very much difficult, and it was inefficient also for adding some new information in the LLM model. So that was the drawback, and generalized nature of LLM can be a limitation when it becomes to providing the specific answers. So now it was only a generalized, and it was only a limited when we try to search some information. So LLMs may struggle with the questions or tasks that demand deep domain knowledge or the expertise. So these are the drawbacks and the problems that we face in the LLM, and it was not able to use with the GPT-4, and it was only able to use only with GPT 3.5. So due to these drawbacks, we are going to solve these problems using a LAN chain. So LAN chain, it's a framework designed to simplify the creation of the applications using a large language models. So the drawbacks of LLMs are overcome using a LAN chain. So LAN chain, it's a framework designed to simplify the creation of applications with the large language models. So as the language model, the integration framework, LAN chain use case studies largely overlap with those language models in general, including the document analysis, the summarization, chatbots, and code analysis also. So you can see why the LAN chain. The LAN chain overcomes the problems faced by LLM, which I discussed in the previous slide. So LAN chain processes a new text by. So now you can see from this diagram that uh, 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 the LAN chain, we try to convert or break down your data, a huge amount of data, that is large amount of data, into chunks, and that convert into chunks to vector, and finally search to get the similar results. So whenever we say the breaking of a large data into a smaller manageable segments, that is chunks, and we convert that into a vector database, so it is ensures that data is processed efficiently without losing any contextual integrity. And finally, we are going to search that those items or similar items are generalized, summarize, and search those items finally. And this was introduced. This was introduced by the Harrison Chase, invented by Harrison Chase, the mastermind behind the LAN chain. So it took the first step by making the initial comment on October 2022. So it empowers the language models dynamically interact with their environment, unlocking the new levels of adaptability and the responsiveness. So what is this LAN chain? So LAN chain has become a powerful framework for large language model, that is LLM applications in recent times. The LAN chain provides a sophisticated framework to interact with LLMs, the external data sources, prompts, and user interfaces. So the LAN chain is an open source framework designed to simplify the creation of applications using the LLM, that is large language models. It provides a standard interface for the chains, lots of integrations with other tools, end-to-end chains for common applications. And whenever we say chains, it refers to the sequence of calls. A chain is a series of automated the actions from the user's query to the model's output. Okay, and like for example, developers can use a chain for connecting to different data sources also. So now it allows AI developers to develop applications based on the combined large LLM, that is LLMs such as GPT-4. And this was not able to generate in GPT-4 in the case of LLM. So with external sources of computation. So this framework comes with a package of both Python as well as a JavaScript. So this framework can be developed using a Python also as well as the JavaScript. And the main core idea of this library, we can chain together different components to create more advanced use cases around LLMs, chains, and many consist of the multiple components from several models. So, and next, we are moving to the components of LAN chain. So LAN chain is open source project. Since it is launched, a project has gathered from over 54 thousands of people. So GitHub stars, which shows the popularity and acceptability of this project. So now there are many components in the LAN chain. For example, we have chains, agents, memory, indexes, chat models, embedding models, output parsers, callbacks, text filters also. And only a few are shown in this diagram. So there are almost 8 to 10 models, 10 components are present in the LAN chain. So first is a change. So a powerful feature that allows user to combine multiple components into a single applications. That is done by using a chain component. And next one, we have the agents. So these act as an intermediaries between the clients and the service providers, facilitating the execution of language service contracts. And the next component is a memory. So memory allows LLM to store access information from previous interactions, so which is important for the tasks like question answering, summarization, and chatbots. And the next one component, we have the indexes. So this data structure support efficient searching and used by the retriever to find and return the relevant documents. And the next one, we have the chat models component. So these are the variations of LLM that use a chat-like interface to take an input and return the output text. And the next component, we have the embedding models. So LangChain offers the wide range of LLM integrations, including more than the implementations of text embedding model integrations. And next we have the output parsers. So this manage and refine the responses generated by the model and can eliminate the undesired content. So tailor the output format, supplement the extra data also. And next we have the callbacks. So callbacks also uses to register the functions that executed after one certain event, such as the completion of LL operation. And finally, we have the text splitters. So it's a recursion text splitter model, can give or split the text recursively, trying to split all the text into different characters until the chains are the small enough. Okay, so LangChain, it's mix of many components that what I discussed, like chains, memory, agents, callbacks, so all those things. So this is about the components of LangChain. So next one, we have the prompt templates. So these are the templates that accept the user input and output parsers that format the output from the LLM model. And so this is how to import the LangChain, import prompt template. So that's what is the user question has to give. I want to you to act as a naming consultant for new companies. So what is a good name for the company that makes a product? So this will be the question or a template or a string prompt question. So prompt template input variables particular a product, and these are the templates that accept the user input and output parsers that format the output from the LLM model. So the prompts are the LangChain provide first class support for the prompt engineering through the prompt template object. So what we have seen here, the prompt template object. So we can give as an input variable as a prompt, as a text or a string. So prompt template serves as structured guides for formulating queries for language, all the different types of language models. So this templates typically comprise the directives, the selection of the example inputs, and tailored questions and context suitable for specific types. The aim of this LangChain is to design the templates that are compatible with various language models, enhancing the ease of transferring templates between the different models. So in short, you can prompt template class to create the different templates for a string prompt. So now you can see from this a small piece of a code from the LangChain prompts, import the prompt templates, and prompt template is equal to a template from a template where tell me the objectives or joke about the content. So, and it is a format where it decides the adjectives as a sad or the content as the data scientist. And again, going in detail about the prompts. So what if you are building a chat application where you need to save and send the message history to LLM every day? So time a user sends a new message, doing this manually. So it is a very much time consuming. For supported the chat models, you instead use a chat prompt template. So in the LLM, you would find some sending a message. It was very much time consuming, and that models were not supporting with a very fast. And instead of that, using a chat model, so we use a chat prompt template. So this was imported from langchain.prompts import chat prompt template, and this is can ask or send a message from an input. So you are the helpful AI bot, your name, then from the human like hello. So are you doing? So I am doing well, thanks. And from the human input or from the system. Okay, so it translates or go with the sequence of the components and tries to convert into a final result that it can be searched or get to a user. Okay, so now that is it goes to a sequence of all the components like the chains, agents. So it can chain up with the many prompt strings, agents, memories, indexes, and chat models, embedding models, and finally it parse, callbacks, and spread. So why do we need a prompt templates? Why can't we directly pass this string prompt to LLM? So prompt templates are usable allowing you to create a prompt once and use it for a multiple situations like the summarizing different articles without rewriting the prompt each time. So they separate the formatting of prompts from an actual model invocation, making the code more popular and allowing the independent updates to the template or the model. So using these templates improves the reliability of your code as they encapsulate the complex logic in a simpler format with a clear named variables. So you can see in the from the above chat prompt templates. So it is very much clear what the variables you are defining and simplified. So maintenance becomes more easier with the prompt templates as changes to prompt logic need only be made in the one particular central place rather than in every individual prompt. So now this prompt templates, what we have defined in the LAN chain. So these templates are reusable. So you can use many number of times, create a prompt once and use multiple situations like summarizing without rewriting the prompt each time. And these prompts like our code are more modular, allowing all the independent updates, template and the model. And this code improves the readability of your code and it makes simple format. So with clear named variables and the changes can be adopted in one central place than in every individual prompt. So now this is the main core of the LLM. You can see from this figure. So there is the many models. There are many core models of LLMs, whether closed or open source, that serves as a foundation of many applications from the year 2018, 19, 20, 21, and 24. With respect to the model size, in billions of the parameters. Once we can see that the BRT, a very large model, so which is used to take around 340 million. So BERT is a bidirectional encoder representation from the transformers, and it is in the natural language processing NLP developed by that is Google. And Megatron, it is a very open source uh, based library that contains a GPU optimized techniques and cutting edges systems and level optimization. And TS is a time series, and you can see this GPT. So this is generative pre-pertain transformers, and you can see the number of the users or the model size in billions of parameters. So 175 billions of parameters models you can see in this GPT, and turning out the Megatron turning into NLG, which is of 530 billions. So this is one core LLM, so that contains many models, so that like BERT, GPT, Megatron, TS, GPTs, and turning, and Megatron turning. So next, we see that agents use this LLMs to decide what action to be taken place. So as I told, agent is one of the main component of the LAN chain. So agents, these act as intermediaries between the clients and service providers, facilitating the execution of language service contracts. And I can see from this. So the instruction which is read out loud by content of any image. So now there is a prompt or a string prompt, so which will ask you to perform a task. Your job is to come with the series of simple commands in a Python that will perform a task. So you can print the intermediate results if it makes sense to do, and like tools used to this for this prompt like image generator, image captioner, and text to speech. Now these are the set of examples or tasks read out loud the content of a particular image, and there are tools used for to image generator, image captioner, and text to speech. Now this agent will try to act as an intermediate between the clients and service providers. So it is used to facilitate the execution of all the language service contracts. So I'll use this image as captioner for to caption the image and text to speech to read it out. So now I can use with a Python with all this agent and generate like a generation where finally got generated a text, the river flowing through a frozen forest. So now agents, the fundamental concept of agent involving utilizing the language model to select the series of actions. So unlike the chains, so where the sequence of actions is predefined and embedded in the code, agents employ a language model as a decision-making tool to identify the appropriate actions and their sequence. So there are three main key concepts in the LangChain agents. So one is tools, user input, intermediate steps. So tools are used to describe descriptions of available tools to LMM. And the second one is the user input, the high level objectives of the task. And the third one is intermediate step. So any action or a tool output phase previously executed in order to achieve the user input. So these tools represent the functionalities that an agent can activate, or any two crucial aspects of tool design include like ensuring the agent has accessed the appropriate tools or not, and defining the tools in a manner that maximizes their usefulness to the agent. For various routine activities, an agent requires a collection of interconnected tools to address this, or LangChain introduces the idea of toolkits. Like LangChain offers a broad range of toolkits to get started. So LangChain not only specifies the process of identifying the process of interacting with the different language models, but also maximizes the efficiency and the relevance of their outputs. The features like a prompt template and memory in a LangChain demonstrate thoughtful integration of flexibility and precision in the prompt engineering. So catering to the wide range of tasks from a simple queries to complex conversational text. So the advanced features in the LangChain chains and agents further the potentials of application that can be built using a LangChain in just few lines of a code with any underlying choice of LLM, and there many choice choose from. Okay. So now this is the memory model, or memory component, what we discussed in the beginning. So memory model, it's one of the main component of the LLM, so LangChain. So this allows LLM to store and access the information from previous interactions, which is important tasks like question answering, summarization, and chatbots. Now, so the memory component allows the chains and agents to have both short-term as well as long-term, enabling them to recall or any past interaction with the user. So you can see from this human, one conversation that is happened in this. So human, good morning, So yeah, good morning. It is beautiful day today. Is it? And how can I help you? So human, my interest here is to explore the potential of integrating a large language models with external knowledge. And AI, so interesting, large language models is a type of artificial intelligence and so on. It describes about the complete about this. And human, I can just want to analyze the different possibilities. What can I think of? So well, integrating large models with external knowledge can also open up with a lot of possibilities, and it gives a complete examples. So this is how the interaction takes place in the memory component. So as I told that it is used to store and access information from the previous interactions. So which is important for a task like for question and answering and summarizing and the chatbots. So next we have the memory, and so in the language model, the applications that involve the chatting. So it is very important for the system to remember the past conversation. So just like a normal chat, the system should be able to look back what was said before, and this ability to remember the past chats is called a memory. So memory will store and access the information from the previous interactions, and LangChain helps and memory for this chart systems. So as a memory in a LangChain does two main things. So before sending the query to LLM, and once the response is returned from the LLM. So it sends a query to LLM based on the past, the interaction, the information which is stored, and which is important for tasks like question and answering. So you can see there are two steps or two main things. So one is the question which is given to LLM, and what is the response once it has returned from the LLM. So now, so it works based on, as I told, it works based on the access information store and information based on the previous interaction. So now before sending the query to LLM, the system reads from its memory to enhance the initial input prompt into receipt from the user. Once what is the query from the user? So once the response is returned from the LLM, it writes to memory for further interactions before returning to the final output of the user. Okay, so it writes to the memory before writing to the user or giving the output to the user. What is the question from the user? It reads, and this is a response that is it has got from the LLM and writes to memory before presenting or giving an output to the user. Next, the chains. So now for simple tasks, and this is one of the main component in the LAN chain. So it is a powerful feature that allows user to combine the multiple components into one single application by using a chain. So chain is used to combine multiple models and components into one frame or one application. So that is called a chain. So now using a single LLM, the large mod LLM works well. However, it was more complex task and usually requires training of multiple steps or as well as models. So now in the LLM, it was working well, but it was very much complicated if it was very large models. So now due to this, so chains was introduced in the LAN chain, and it is used to combine multiple models into one single application or one single model. So the legacy way of using this chain in the LAN chain is through the chain interface. The never and recommended method is the LAN chain expression language. So although this LCL is preferred for a new project, the chain method is still useful and supported. And the chains are what you get by connecting one or more language models, that is LLM, in a logical way. So chain can be built of entities other than the LLMs, but for now, let's stick with the definition of the simplicity. And the OpenAI is a type of LLM provider that it can use, but there are others like Cohere, Bloom, and Hugging Face, etc. So here, some of the example used with the chain, combine the multiple models in a single one application, and it allows user to combine multiple components into one single frame or one single chain. So chain from a LAN chain, so LLM import OpenAI, the LAN chain with the chat models import all OpenAIs, and import the prompt template to read any text or a string prompt from the users, and import the string to the output parser. So finally, you output the parser to manage and refine the responses generated from the model, and where it can eliminate the undesired content or the tailor out the output format or supplement the extra data. So using this parser and chat OpenAI. So OpenAI key. So and the chat prompt template from messages. So any user can request a message and combine a chain with a multiple user requests with a chain model. So it combines multiple chains model, and for chunk in runnable stream. So how it's the machine learning different than the deep learning, and the way runnable is created is not standard or for a Python, but it's a pipe operator. So prompt model, or we using a standard output parser, would mean that prompt is passed through a model and the output of this then passed through the standard output parser. So each segment in the chain transforms the data in some other way from your standard the chat prompt template to the standard output parser. Okay, so it transfers your data to in the one another way by using a chain. Now let us see how this LAN chain works. So LAN chain organizes the vast amount of data that LLM can quickly access with the minimum computational resources. So this is how the working of chain. So LAN chain, it collects the data from a very large model, and it's a framework where it's designed to create many applications, many large language models. And so you can read your data from a large PDF and convert into all your data into a chunks. So chunks will break down your large data set into smaller manageable segments, or called as chunks. Okay, and we try to convert this into vector databases where it try to ensure that data is processed efficiently without losing any contextual integrity, and it stores in a like a databases that is in a vector format. So we transform the large document into a numerical representation through vectors. We can combine them into finally LLM, and it is very easy to access with the labeling. So, and you can see here, so this large chunks from the any data, any large model is divided into pieces, and then that is mapped or into converted into a database to a vector store where it is each model into a label format. So each model or each data is into a converts into a label format. Then it is very easy to access and preserve the data. So now how this LAN chain works. So this allows us to create allows us to retrieve specifically the information we require for creating a prompt. So the completion pair and LangChain, it is like a mini Google. So from your vector store, I can use a prompt template to search any content. So using a prompt string, and this data, this prompt text, it directly goes and fetches the data from your vector database or a database and find out or generalize some relevant information retrieval. So through this LLM model, and finally complete with relevant information and gives the result through as a reply. So it directly contact to a vector store or a database, or it connects to the LLM mini models and retrieve the information with the relevant information. So now next one we see how actually this the applications of the LangChain. So first one is a chat box, the generative question answering, summarization, the personal summarization, personal AI email assistant, AI study buddy, code analysis, data augmentation, text classification, text summarization, and machine translation. So one main application is a chatbot. So it is a like a computer program that simulates and processes the human conversation. So either by written or spoken. So allowing the humans to interact with the digital devices. So that is the first application of LangChain, that is a chatbot. Second one is generative question answering. So it retrieves the most relevant content and the LLM waves into a coherent, insightful answer. So this processes the mirrors of human inspired the way of understanding and the cornerstone of any generative questions answering approach. So that is done by using the generative question answering. Next, third one, the application, we have the summarization, the process of automatically condensing and rewriting a large chain of text into create a small and crisp summary. So it will finalize, create a large model into a one common, that is a summary. So that is done by using a summarization. And fourth one, we have the personal AI email assistant. So ultimate email management tool that revolutionize the way you manage your mails. For example, like we have an example like missive mail butler. So that will revolutionize the way that you manage your mails. So that is done by using a personal AI email assistant. And next one, we have AI study buddy. So provides it, this application provides a learning aids which include summarizing the content in a text boxes, textbooks, highlighting and explaining the key concepts in the form of the flashcards. Okay, so that is the application of AI study buddy. And next one, we have the code analysis. So code analysis automatically the code analyzer or analysis. So source code analysis, it is the most popular application. So like for example, we have a GitHub, the Copilot, Code Interpreter, or Codium. So likewise. And next one, we have the code augmentation. So code augmentation artificially increasing the training set by creating the modified copies of a data set using an existing data. So that is done by using a data a code analysis and the data augmentation. So next one, next application, we have a text classification. So classify the text into a labels. So labeling a document with the classes such as a sentiment or language or a style form. It may be a style, formal or informal, or the cover topic or any political tendency. So many classification can be labeled that what the data or a text or a large model into summarize and the text classification. So next, the last one is a text summarization. So LangChain can be used to summarize the text in a specified number of words or sentences, that is done by using a summarization. So creation of any short, accurate, and fluent summary of any longer text document. So that is done by using the summarization, and it has mainly two approaches. One is stuff and one is the map. So in the stuff, we are going to simply stuff all your documents into a single prompt, and in the map reduce, so we summarize each document on its own in a map step, and reduce the summarizers into a final summary. So next, last one is machine translation. In the machine translation, the LangChain can be used to translate the input text data into different languages, so without any human involvement. So these are the some of few main the applications of the LangChain. So the chatbot, generative question and answering, summarization, personal AI email assistant, AI study buddy, code analysis, data augmentation, text classification, text summarization, and machine translation. So now let us see how to set up your LangChain. So now, so any this LangChain can be implemented in Python or JavaScript. So you can directly install with the command pip install LangChain or pip install OpenAI. So then once you install this LangChain, so you try to import all these LangChain libraries and OpenAI import OS for combining many LangChains using LLMS, and OpenAI and use this the OpenAI embedding for a LangChain and retrieve all your questions, retrieve the question answering from a LangChain. Try to convert, if you want to convert this, import all these libraries to perform all your LangChain operations. And one API configuration, that is API key is equal to get env OpenAI key. So can give any question that will be converted, summarize, convert, and parse the answer. So interacting with LLMs using a LangChain. So interacting with LLM using a LangChain involves a series of steps that allow you to leverage the power of pre-trained language models such as GPT 3.5. So now, so this LangChain will be interacting with LLMs. So with version up to GPT 3.5 and above 3.5 is not allowed with the LangChain, and that is also a drawback with where LLM cannot use the version GPT with LangChain. And for the next generation and understanding task, the LangChain provides a seamless environment to generate the LLM powered applications into your workflow. So first thing is we need to initialize the LLM and input your prompts through string prompts. Now from LangChain, import the language model. To specify the language model, you need to use the model name as GPT-3 or 3.5. So that is the name model that we use the LangChain where we can integrate with LLM and initialize the LLM. So LLM as language model and the model name, and input the prompts, input the text from a user, and input a single in prompt. So prompt, once the prompt given up the time, so generate the text based on the prompt and read the text, and finally convert the result. And next one is retrieving the generated text or responses. Once you have inputted your prompts, you can retrieve the generated text or responses from the LLM. The generated text or responses will be based on the content provided by the prompts and the capabilities of language model. So now we see some example like print generated text, print generated text, print the responses. For responses in responses, and print all your responses. So finally, so now, so that is the final working of the LangChain. So you request your data, try to convert that into a response, and before giving a response to an user, it stores in your memory, and then it is given the response to the users. By following these steps, implementing the corresponding code, you seamlessly interact with the pre-trained LLMs using a LangChain, harnessing their power of various text generation and understanding this task. So now last one, we have the case studies. So there are many case studies in the LangChain. So first, some of the case studies, the LangChain with the paradigm. So how paradigm runs, monitors thousands of agents in parallel with the LangChain and the LangSmith. And second one is Athena intelligence. So how this Athena intelligence optimize the research reports with the LangSmith and LangChain and the LangGraph. So, and the third case study, like the LangChain or the wordsmith, the Landsmith for full product lifecycle, how Wordsmith quickly builds the debugs and evaluates the LLM performance in the production. That is the third case study. And fourth one, where like we have the LangChain with the new computer, improving more memory retrieval. How new computer achieved 50% higher recall with the Langsmith. So new computer uses the Langsmith to improve the memory retrieval. And next one, we have the LangChain factory. So factory used with the LangChain Smith to automate the feedback loop and improve the iteration speed up by multiple times. And next one is Rakuten groups, that is the LangChain case study group builds with LangChain and Langsmith to deliver the premium products for its business and clients and employees. And next one, we have the LangChain, the command bar. The LangChain partners with the command bar on their Copilot user assistant, or the LangChain Elastic. LangChain Elastic partners with Elastic to launch the Elastic, all the assistants. And finally, the LangChain Ally. So financially, any collaborates with the LangChain to deliver critical coding or module to mass the personal identifying information in the compliant and safe manner. So these are some of the case studies of the LangChain. And if you want to try to install this LangChain, so go with the pip install LangChain, or and also install the AI models, and the many libraries will be installed. So by importing those packages, so you can implement this LangChain. So these are the case studies of a LangChain. So prompts being input to the LLMs are often being structured into ways that we get from the different results. So the question and answers, you could take a user's question and reformat it for different question and answer styles, like a conveniential or bullet list, or even a summary problems relevant to the given question. So creating prompts in a LangChain. So this is all about the LangChain. What are the drawbacks of LLM and how it is overcome using a LangChain? How the LangChain can be integrated with LLM? What are the components of LangChain? What are the applications? And finally, the case studies. So this is all about the LangChain. Any doubts, participants?
Hello.
Hello.
Girish sir, I'm audible.
Yeah, madam.
Okay.
Any doubts? Any doubts? Can ask or can message me. So thank you for all the participants who participated in this session.
Sir, can we run any one example and show, sir? Okay, sir. Theoretically explained, we have understood, but still in mind, some not have that much clarity. Is it possible to run any one example just for 5 minutes and show? For example, prompting with a long chain with ChatGPT. It is allowing up to 3.5, you told, no? Maybe anyone, already I think you have done that practical experience. Maybe if you show, it will be some more confidence will get set. Just to know, because we don't know that way. We are just using ChatGPT only. But how to interact ChatGPT with respect to long chain? Is it possible, sir?
Yes, sir. Yes, sir. Yes, sir. I'll try, sir. I'll try.
Yeah, please.
Hello, Girish sir. Hello.
Madam, yeah. Sir, Gopi Krishna sir, I'll try to able to connect. Right now, the next speaker is waiting, sir. He'll connect and I'll share you all the videos how to
Yeah.
work this connect
Okay, sir.
the live examples. I'll
Okay,
show you,
sir.
sir.
Okay. Okay, sir.
Thank
Thank
you,
you.
sir.
Thank you for all
Thank
the
you so much,
participants who
Girish
attended.
sir. Our next speaker for today's session is Mr. Sagar Dutt, a senior engineer supervisor. He's having 10 years of experience in industrial automation. Sagar sir has a strong background as a full stack developer. But with his current leadership role, he is managing two key modules of Honeywell's Forgo platform. Especially, he oversees the IoT and cloud integration modules, which serves as a unified platform for connecting all Honeywell smart devices to the cloud and maintain the data pipeline for Honeywell Forgo product. We are welcoming you, sir. Sagar, sir, are you?
Yes, thank you so much, ma'am. Thank you so much
I'm
for the
audible?
introduction. Yes,
Sir.
yes.
Welcome
Uh,
you,
thank you,
sir.
ma'am.
Yes, the mic is. I mean, you can take over the mic, sir.
Sure, ma'am. So let me know if you guys are able to see me as well. Am I audible?
Yes, sir. Yes, sir.
Yeah. Hi. So good morning, everyone. It's a great pleasure to me to come in front of all of you and take 1 hour of all of yours, try to explain what I do and how we are actually using the AI basically in our day-to-day industrial use cases. So as we all know that industries have been in this era from almost like 18th century onwards, and it has evolved over and over in the years. And till today, we call it an industrial revolution 4.0. So what I have tried, or what I'll try to do is what I've tried in my slides to keep it very short as much as possible, as I cannot capture much of it. But what I would try to do is that by end of this presentation, you guys will be able to understand that how AI is actually being incorporated into our industrial use cases. What is the most used AI use cases where you can see all the industries are basically focusing on, and what stays on top of the whole pipeline of this AI. So that would be my um, goal to explain you all, and would like to open this forum to you guys to set your expectations, so that if at all, if I have some key items element added to my presentation, I can emphasize more on it. So what are your expectations? If few of you can actually just speak out so I can note it down.
Good morning, sir. Maybe some because most of the speakers they are focusing only on presentations, theoretical part. We may not be get okay. We are getting ideas unless if you see with some examples, small examples, no need big examples, so that it will be useful, sir.
Yep.
That's what I have been waiting, but I am not getting that one, sir.
Sure.
Yeah, kindly, if it is possible, maybe please, sir.
Yep. Sure. Okay. So any other points? Anyone? Okay. So I'll kick start. Are everyone able to see my screen? Is my screen visible?
Sagar, it is visible, Sagar. It is visible. Manoj
Right.
here.
Okay, thank you, sir. So I'll proceed. So guys, of course, AI is the new superhero. We call it everywhere. I think each one of us are hearing that at every beat industries, hospitals, finance, banks, social media, mobiles, everywhere AI has been pitched in everywhere. Everyone is saying that we are AI ready, we are using AI, we are powered by AI. But really, each one of us, whenever we are listening to this statements, are we really realizing that what is the main pillar or what is the main background of AI? There have been AI, many modules, many engines, Chat GPT, but for all of them to work, basically, how are they working? How are they getting the data? Of course, modeling anyone can do, but are we really knowing that whatever models are we creating, is it right? Is it working? So there are so many other questions relies along with AI. So basically, AI is not just about modeling. AI is also to get a proper data inside your data system, set up proper pipelines. That means the source of your data till the destination, what is your outcome? That is actionable outcomes from these data using an AI is whole of comes under the AI background. So to begin with this statement, what I want to say is get ready. AI is becoming the new superhero for every new industry. And uh, it will be fun going in, in coming years when we will see that AI, we are already wearing it, but inside us also the AI will just pitch in. But then we need to really understand that how AI is actually getting into us and how actually the AI is working. So that will be something very dramatic and going forward it will be very interesting as well. Today we are just seeing on our computers, laptops, AI, wearable watches, digital, but how it really gets into the neurocells and all, we never know. So understanding from where this AI is coming, we need to understand where is the top investment goes in. The today is the top investment at any given point of time goes into the industries basically. So whatever we are seeing as part of the social media or any of these new mechanism or open AI and all these things, these have been already been into the place, but it was underfunded, or it you can say under many of the IPs basically, which was under captured under the industries. So to start begin with, we need to also understand that what sort of data is being used and how do we use these data for our AI modeling and all. And especially today, I'll keep my talks only till the industries. And because industries, we always know that there are many mission critical industries. That means even a small mistake or even a small error can take life. We have seen so many such in past. I think one of the biggest one which I have been seeing in the Netflix was that Bhopal gas strategy, if you guys all know, right? So these are all small errors which causes a threat to the human life, and also in this mission critical systems on industries also the AI is there, and their AI is actually working much more effectively, efficiently, just because the data input to them and the way that modeling is happening on the data is actually focused more than the modeling part. So we are in industry 4.0 basically, a revolution which has come in. And this industrial 4.0 is actually basically all we talk about IoT. The IoT word nowadays with AI, one more term which keeps on coming to our ears is IoT and big data. Then we have this cloud computing, advanced robotics. These all things are part of 21st century, which is the industrial revolution. Then the question would come, then what was 3.0? Sorry, yeah, 3.0, 2.0, and 1.0. So these are all older revolutions. So basically, the 18th century one was 1.0, where everything was labor intensive. Then mass production came into the picture, which was 2.0. And then 3.0 was the mid 20th century, where you can say the computers and, just very basic minimal computers. We would have heard about PLCs. So those were used to run the industries and automate it, just very fixed logic. That's when we make the logic flexible using AI and all is our industrial revolution 4.0, which is nothing but when you want to make your any of these models, your AI models flexible and it has to change. Basically, that can only happen when you are getting a real-time data, and that real-time data without least lag possible, and that is only in this era is possible through IoT, which is our Internet of Things. That means what? When we say Internet of Things, that means my device, which is capturing these data, basically, which is in the plant, is able to talk to my internet, which is the cloud, because so that the processing sometimes cannot be done in the like in premise. In premise, costing of the cost or the cost incur of doing this calculation and computation is very, very high. So that is the reason why there is a shift we see from on-prem to hybrid, from hybrid now we see to the cloud. So bear with me, guys, because what is happening is there is so many things, so many technology at this point of time in this era that it is very difficult to keep that all this information in one single PPT or in 1 hour possible. So I'll try to put these words and jargons that we keep on listening from everywhere and try to stitch them for you guys so that how basically they are working together. So till here, are you guys with me? So uh, are you guys understand that what is Industry 4.0? So Industry 4.0, we have AI and IoT. So today, if the industries are saying that we are onboarding to 4.0, that means they are going to have some smart devices, which is going to talk to the internet, and they will have some AI modeling, AI ML basically suits, which will be doing some sort of predictive maintenance and some sort of advanced process management. So these are the key factors of the industries at today. I'll give a pause here for a minute, and if you guys have any questions or uh, want some understanding of any terms which I have used till now, because this will be the base of the foundation basically for the next couple of PPTs. Any questions, any doubts, any or any topic you want me to repeat or want to understand further? Okay, I'll move forward. So basically, now that we know that AI and IoT will be used in the industries, so how are we leveraging them? What is the leverage point of using these are basically, as I already said, that it is to make our industries production much more efficient. Overall productivity has to be increased. It has to be seamlessly operating without any downtime or the least downtime possible. If I have to say today, if you see Google, or you take our Azure cloud services, they say the uptime or the SLA of almost 99%. So those are again digital factories, I'll say. Okay, there's of course there are hardware, there are servers, there are down, but again these are not much of those hardware where there is a friction or there is some sort of combustion happening there, right? Whereas in the other factories and industries there are many more moving uh, these are machineries there, much more which is much more prone to torn, which will wear and turn. So basically what will happen is if you use for 100 hours or something like that, you have to give them a cool down period. So then you need to have some sort of any another plant operating the same time to still keep the efficiency up and right. So for that reason we need that AI ML suite, the IoT basically, to increase the efficiency of the system. Moving ahead. So basically, when we say industry and when we are saying IoT and AI in industries, we are very heavily dependent on data. So when we say data, there are basically foundational three types of data that in industries we work around. One of them is time series data, and then alarms and events. These are the three fundamental data that is being used in industries today. Anyone having any questions on before I explain what is time series, alarms, and events? Okay, so Okay, so now, as I say, there are time series data. You guys are able to see my screen? It's still visible, right?
Yes, sir. We are visible, sir.
Yeah. Am I going too fast, or is it okay? The pace is okay?
No problem, sir. We are understanding. I am understanding.
So, okay, so I'll move back. So basically, we have this time series data, right? So time series data is, once again, sorry, I think my screen is, once again. Yeah, time series data. Yeah, now I think it is showing. Yeah, the time series data basically. So time series data is nothing but this is actually captured. Say I have a motor. Motor is running basically. So when the motor is getting run, it is gonna take some power. It's gonna consume some power. Say at any given point of time, it is taking 100 watts per second. So my time series data is nothing but what it will do is it will say at say today, right now, what is the time? It is at 11:19. And we'll get to the seconds also, maybe 30 seconds. The consumption is 100. Then it goes 11, 19, 31. It goes for maybe 101 and then 100. So like this, the series, basically the whole series is nothing but your time series data basically. So just I'm trying to explain what all data it is and then how it will be used in AI and IoT. I'll let you know. So this is your time series data, and then comes your alarms basically. So alarms are nothing but in case we set up some in our motor only we have coded because we have some special modules. You guys might have seen Raspberry Pi like this. PLCs are there. There are some other modules are there in industries which actually keeps on maybe uh, setting the temperature of the motor. So basically at this point of time, this motor might be at 50 degrees Celsius temperature. And we have set an alarm where we are saying that if at all this reaches to 100 degrees Celsius, you need to send a alarm to the system. So what will happen is as soon as the temperature goes up, maybe during the summer time, when the motor is keep on running on very heavy load, the temperature might reach at 100 degrees Celsius. And at that point of time, one event will be, alarm will be triggered that the temperature has reached 100 degrees Celsius. So this is another type of data which is available in the industries. And then the last one is nothing but the events basically. So events are nothing but once the alarm is triggered, the alarm will not reach to the end user or to the cloud or any of the higher in the pyramid systems. It has to be notified. So that notification comes from your events basically. So that means when events will put a log saying that at 11, say right now it is what? Right now it is 20. At 15 second, there is an high temperature alarm raised. So something like that. So this becomes your event. So these are the three basically data types which will be used predominantly always in the industries for your AI and ML. And how this reaches to AI ML is through IoT devices. Did it make sense? We'll
Yes,
get
sir.
we'll get to a very detailed flow. It is just to understand what we say when we say time series data. What is time series data? What is alarms and what is events? Okay, we'll move forward. So as I explained already, so the AI algorithms, right? The AI algorithms can only work when we have data, and this can only happen when we have an IoT in place. And this IoT is the actual person who gets the data from your any of the field devices. So we say smart devices. When we say smart devices, smart AC, smartphones, anything, because it has a connectivity to internet, able to transmit data is nothing but our smart devices basically. may not be necessary that it's doing any sorts of processing. The processing is happening somewhere in the AI/ML, where the AI/ML module basically. So as it is said, this is coming up from again from industries. So AI algorithms we use to enhance the efficiency of the industries, and to make them more, to make the AI to work, we need to make our industry smart. That is nothing but smart industries. Smart industries is nothing but IoT enabled. So what happens when we get the data now from the industries out, and what are we trying to do from the AI basically is that we are running many of the aggregations, many of the transformations basically. For an example, you have a thermometer at your smart thermometer, right? So the smart thermometer is there and it just captures the temperature at degrees Celsius, and it has a connectivity to my cloud. It's a Azure cloud. I have a dashboard given to my end user who is actually looking into this temperature. Now, this guy is sitting in India at this point of time, and he is very much interested to see the temperature. And we in India are much more familiar or much more familiarized with degree Celsius. But as soon as we go to the US or any of the Europe or basically US side, they are more into degree Fahrenheit. So if at all, if degree Fahrenheit has to be supported in my dashboard, what am I going to do? Am I going to tell my smart device itself to have this degree Fahrenheit also capture the same temperature in degree Fahrenheit and then give it to me till here? But this is waste of processing in any given point of time. So what they would have done is we would have thought, okay, instead of doing it there, we will make our UI itself smart to convert it into degree Fahrenheit. So this is nothing but end of the day, what we are doing, we are setting up a model here. The model is not learning, but what we have told is how to convert degree to Celsius. We think that AI is very, very something which special or something like that. But end of the day, we are just reinventing the whole thing and just making it automated. That is the only thing what we are doing. So when we make these models automated and it's learning on its own is nothing but AI/ML. Am I making it simple for you all? So I think we have done this changes quite a long time, but we never knew that the formula that we write is nothing but a model only end of the day. Okay, moving ahead. So I kept this blank, this page, because as I think one of one of the listeners was also asking that we wanted to understand more um, like examples basically instead of theoretical. So I kept it blank for the same reason, where I would like to explain and take a use case basically and explain you all that how basically a data flows all the way from the industries to the dashboards and how it is helping actually a supervisor who is working in the industries basically, and how the AI/ML everything, how the data is getting processed, what all modules we use in the processing. Because many of the things I'm a little limited, but because of the IPs also, that is the reason why I'll try to keep few things very black boxes, but I'll try to give the connectors and all information as much as possible. And please stop me if you're not understanding any of these connectors. Because there is no presentation, it is very difficult to put it in one PPT. It becomes very vast and all, and very difficult to, very easy to, get lost in that. So I'll draw it for you real time so that we only focus on the component wise, and we are able to ask questions also on the component wise. Fair enough? Okay.
Yes,
So
sir.
I have
Yes.
taken a use case. So a use case is we all are sitting here in each one of us in the house, room, seminar halls, powered our laptops, powered our all equipment, gadgets. All these are coming from power plant. And for the power plant, the main ingredient for which it needs to generate the power is coal. And the coal is coming from open cast coal mines. So what we will do is we'll try to understand how our AI is basically integrating into this whole use case, and at what stage it is getting used, and how it is making an impact. So basically what happens, we'll try to do a from the top bottom. So what I have is, we have our laptops. Sorry. We have our laptop hooked up to power, right? So we have this power coming from our power grid, the power plant, I'll say. So at this point of time, for this guy to produce this power, we need coal. So we need coal basically. And to get this coal, it's coming from a mines, open cast mine. So we have a mine where you can say open cast mine is there, from where the coal has to get transported all the way to the power plant. To do that, they have set up a very, this is a Soviet Union time fundamental thing, which is they called merry-go-round. The merry-go-round, not in the park one, which we see that round thing, but what happens is, in this, the railway track is set like this, like a circular thing, and the train keeps on going in a circle way. It is there in our MP, UP, Bihar side, in all the major NTPC, VSTPP, all of them power plants, they use the same fundamental thing. So they have a train, they have 30 bogies in that, and it keeps on going in a circle. So it goes to the mine, fills the coal, and then it goes to the power plant, dumps it, and again goes. So this is a circle. And in this, what happens is, when it comes to the mines, how to load this coal into this, they have a big silo. And silo has a small opening in the down from where the train actually goes through. It's on the track only, it's on the tracks, and the silo is filled with coals. It's like a funnel. And from the mines, there is a conveyor belt. So whatever the mining happens, they put the coal in that, the conveyor belt takes it up all the way. So it's something like this, you can feel. So the coal goes from here, gets stopped here, it gets into the train down, which passes through, and it goes to the power plant. Now, what happens is, because this transport is almost 50 kilometers away, the coal sizes, the pieces which is there in this bogies has to be, there's some certain weight and size which it needs to be. So to maintain that weight and size, there's another machine which is there in between, which is called the crusher house. So which maintains these chips in a proper shape and size. Now that crusher house gets these coals, it puts it into the conveyor belt, gets into the silo, loads into the train, and gets into the power plant. Power plant uses the coal to fire it up our boilers, produce the electricity. Now we are getting the electricity to our laptops. At this point of time, as per you all, which of the element is most important here? Maybe I'm just asking you, like 1 point failure. Okay, so
Dumping,
sorry.
dumping coal into the train, sir.
Yep, right. So this is one of the very major equipment. If this fails, this silo cannot be made overnight, but engine can be fixed There always power plants have multiple gensets, like generator units. So if one is always in cold state, so that if one goes down, the other comes up immediately. Human manpower can be used to extract the coal. It can be even dumped. And to get to this, but there is another thing. The rate at which the coal is burnt cannot be slowed, cannot be faster. If it's slowed down, to restart the whole process of power generation is again a problematic. So even to load this coal is also important. Keeping this whole conveyor belt and the silo is very important. So this together, this is called CHP, which is the coal handling plant. You can read more about these. It's readily available on the internet on these things. So now what the thing is, okay, let's get smart devices into this place. How do we control? So now what is happening is this silo, how the way it is loading the coal, it's all system by computer systems basically. I'm talking in the year of 1999, 2000, where I have also seen this, where people are sitting in those Windows 95, Win 95 machines. There was a DOS UI basically, and it was showing those bogies are going like a graphical unit, and the machine is actually pouring the coal, and it's just showing 30% filled, 40, 60 like this. And the same thing, it's a static, and then the next bogie comes, but this doesn't move. But again, it shows 30, 60 like this. It is going. So it used to keep on doing, and there was a system already just taking care of this. There's a system already. So this is nothing but one system is sitting here, right? I'll say system 1. There's another system which is running these power plants, system 2. Very interesting. Both of them are not talking to each other, but both of them are actually taking care of each of their premise. So system 2 takes care of this, system 1 takes care of this. And when these systems are nothing but, if you would have heard about something called PLCs, programmable logical controller, then you would have heard about DCS, distributed computer system. So these are nothing. DCS is one of the major component. Many of the big players, they make it, manufacture, Yokogawa, ABB, Schneider, Honeywell. So they have a different labels to them, but end of the day, these are DCS systems basically. So now they were not smart. All they were computer systems running. They were actually connected to the, say, now we have a temperature sensor or a energy meter. So all these things through hardware and pneumatic lines. And these were all processed and controlled in the premise only. This is all on-prem. Are you guys with me till here? Okay.
Sir. Yes, sir.
So now what happens is next era came into picture. Oh, this is not fine because there is needing some human intervention to understand this, tell to this that, hey, listen, instead of one laptop, there is 4-5 laptops have just pitched in. Whatever power I was consuming now into 5, I need to increase our production. Means like my fire rate has to go up. I need more coal. Then this guy will call the mediator. Mediator will tell to the coal handling plant, please tell these people, everyone, to increase the production. This is all telephonic. So I'll say human intervention is needed to speed up all these things. So then came smart devices. Smart, so that now can this S1 talk to S2? That was the thing, and eradicate this whole person from here. Now, as soon as my S2 knows that there is a demand, my output is increasing. Basically, my output need is increasing. That means my input, which is the coal, has to get increased. Can I tell to my other system that, hey, listen, you need to send me more coal? So that's when the trigger comes. So now, if you're seeing the system and systems are talking, how can they talk? They are 50 kilometers away. They cannot have a dedicated line. We have internet. So this internet is nothing but our IoT, where this guy is also aware of what is happening within himself and also able to communicate outside. S1 is also able to find out what is happening here and also able to communicate outside. Now we are in IoT. Did I able to bridge the gap? Okay. So next what happens is I'm good. Now I'm able to collaborate. So whenever I see a demand, I'm able to tell. But am I able to forecast the demand? That means what has happened is when I'm in the March month, my input or my output, basically the demand, the energy demand is very high. Maybe when it comes to the December, my offices are down, schools are down. So this is gonna come down. The need or the output requirement will be down. Can I predict it? Will I be able to predict it? How do I predict it? I can predict only by when having data from S2 and S1, which they are already capturing from different points. Right? So when these two data are combined in one place, and I have another advanced process control, basically APC we call it, which is again a common term. This is another central system which reads data from S2 and S1 and decides basically, okay, my December month is upcoming. I need to make sure that whatever parameters are there, everything has to be reduced, because I don't want like on 31st to 1st, suddenly it just drops. It cannot be like that. There should be a gradual drop, because if any given point of time, if there's a small spike, I should be able to take care of it. If I do a sudden drop and sudden there is, but actually the demand still stays there, I may not be able to uh, cater to that need. So at any given point of time, to be fail safe also, we need to be, our model has to be very, very strong. So you're getting my point now, why we say that model has to be more strong, the data has to be more accurate, because if the data are not accurate, we will be making a wrong model and wrong prediction, and which may create more adverse impact basically. Are you guys with me on this?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Is it interesting or is it boring? Let me know,
Very,
because
very interesting, sir. Very, very interesting.
okay, so
Yes.
we are here till here. Okay, now I'm going to whatever I explained, I'll go to the next slide. And this is a very simplistic, as much as possible, simplistic image I have kept it here. And now we will discuss on each of these. I'll give 1 minute, half a minute, so that everyone can see this image. For a minute, if I ask, you see this N part. What exactly you guys think? What is this N I am? And I'm sorry for my this one. This N is actually depicts something in our modern computer language, especially on the smart devices. And when we say AI ML, it is not our compass N for sure. Okay, it is something else. Anyone can give a guess to this. Okay, so
As
N.
of now, I know only as per the directions only, but the first time I'm hearing, sir.
Yeah, okay, so N as per compass is north, and there is something we call it northbound and southbound. So south is down. So as devices, the most smallest entity which is generating the data, or basically like the motor is nothing but the entity, the most basic entity which is actually running in the field and it is generating the data, is nothing but is on the southbound, and our clouds are actually northbound. That means the data is traveling from south to the cloud, which is nothing but north. So the more and more we go up is nothing but northbound. So when we say the northbound connectivity is failing, these terms are being used. So that means nothing but we are not able to talk to the cloud. And sometimes when we are the cloud engineers, we will be say the southbound is failed. That means the south, that is what in the field, the data is not able, the field device is not able to send the data. So this is a terminology which we generally use. So we say northbound data, southbound data. So northbound data is when the data coming from the devices to the cloud. Southbound data is when my AI/ML would have done some sort of processing, some sort of decisions would have been made, and it has to go down to the device to set the value. For an example, many of you have this would have seen the smart devices, a smart AC, right? I'll take an example of AC here. Then I'll come to this major one. AC has today we are able to control it through our actually mobile app, right? And we have a temperature there. Say right now the room temperature could be at 24 degrees Celsius. So this is at 24 it is showing. And in my mobile app basically, which is in my hand, I make it to decrease to 23. So my question is, when this 24, which is the room temperature, this data is going to my mobile is nothing but northbound, because my AC is sitting is the most basic entity which is generating this data and sending it to me is a northbound. So this is a northbound data. And when I'm giving a command to the AC that please reduce your temperature 23, which is coming from our handheld to the cloud, from cloud connectivity, it is coming to the AC is nothing but southbound data. Okay, so this was about northbound and southbound, because many a times when you converse or when you read any of the IEEE papers, these terminologies will be used. So coming back again, so now we saw that conveyor belt last time that we were talking, and there is a motor basically sitting there. So now this motor is in running state again at any given point of time. This motor has multiple parameters that can be measured. One is what is the RPM at which it is rotating? What is the temperature at this point of time? How much heat it is generating? And then what is its uptime? So things like that can be data which can be captured from this motor. When until we capture this data, we just on and off. It's a very basic motor. As soon as it is able to tell us these parameters, it becomes a smart device. Now, how can we get this data? These three types of data can be read through multiple protocols. The most famous ones are MQTT, Modbus, RS485. So again, I'm not getting into each of these protocols, but these are the protocols which is used. They are BACnet. The many are there actually, basically. BACnet, OPC-UA. OPC-UA is another standard basically protocol. BACnet is also there. So different industries will use, like business buildings automation, they use BACnet. OPC-UA is a very general and most used protocol in industries basically. So then what happens is, using these protocols basically our PLCs will capture the data from the smart device. Once it has the data, these PLCs will be sitting in a you can say very high security zone in the industries. Okay, so this is called L2, generally L0 to L2. So in this, they will not have internet connectivity at all. It will just have one port opened for it to connect to only to few of the ports, and that ports we will be reading. So this is like this. So now I'm removing the called IoT, Internet of Things. If you remember the first time when I said if it has connectivity to my internet, I call smart devices or IoT enabled devices. So this is no more IoT. basically, but it is a device which is able to give me this data, the RPM degree Celsius. My PLC is also not smart because it doesn't connect to my internet. Then comes just one more computer system, which is called our edge devices or the edge gateways. This is a new term being used everywhere. Actually, this guy has the ability to talk to internet on 80 port. So port 80 basically. So but it has also the capability to talk inside the industry layer, so that any attacks from outside, our cyber attacks, can be stopped. It cannot penetrate basically into the industries. Otherwise, it will be catastrophic. So for that, for security purpose only, what they do is our internet is only till edge devices gateways. This has inbound with southbound connectivity and northbound connectivity established. So this is the place. Now what happens is once the data comes to the edge devices, say for let's take a this degree Celsius time series data which is getting popped in. So now this what our edge device, the PLCs will do, it will keep on polling, take 100 entries and then pass this 100 entries to my edge device. Now this can be could be in a JSON format, could be in your streams, data streams basically. And once it is having, based on the pull request coming from the cloud, it will dump this data, this degree Celsius, whatever this file we have, say with 100 records, will be pushed into the cloud. Now this cloud can be many way. I have taken an example of Azure. You can say AWS is also there. You have Google today is there. Like this, many third parties are also there. Now you need very first thing in your cloud is a place where you basically capture this data, this raw data, which is coming in. And I can take a best example or at this point of time, which is being used the most is IoT Hub of Azure. IoT Hub of Azure is actually a SaaS service basically, which actually allows you to control these edge devices, maintains the connectivity between the cloud, and it allows you to actually store this data, whichever is coming in, into a storage account, blob storage. Now, once the data is in your cloud, now actually you can do some sort of processing, data processing. So I have 100 records. Possibility is there that my sensor may got wrong here. My sensor might have some fault. So I might want to do some cleansing and all is an intermediary step in between what it generally in the industries it is done. Finally, now it has been fed to the AIML. Here is our engine basically. So once the data is in, the AIML now can finally work on this data and try to give us some insights. What kind of insights are we seeing? What we have 100 records. As I said, one file has come with 100 records of temperature. In that, what the AI would have said, oh, it looks like in the 55th line or something like that, there was a spike of temperature. And also there can be, meanwhile, what would have happened is this is into your storage, right? The PLC sends another file. Now, this time it sends about its RPM. So RPM also, there is 100 records, goes into the cloud, gets into the storage, gets into the AIML. I have this file also now, which is again the time series data in which RPMs are there. 55th line we see the RPM was very low. So maybe 30, generally it may be 100, we are 30, and the temperature could be at 100 degree. So what are we seeing here? There is something going absolutely wrong here, right? But seeing this through a human eye or through a humor intervention is very, very difficult. So there could be some issue that our motor might go bad or wrong in next 4 or 5 days. Now you will say that how do you know in 4 or 5 days? See, at given point of time, AIML may not even know that it will go bad. But what would have happened is I'm maintaining another sheet. One more sheet comes from my PLCs that what is my downtime. which can come once in a day or something like that. Okay, it was down for 10 minutes, it was down for 20 minutes because the wiring, the winding of the motor was bad. So something like that, or someone would have done some RCA, would have felt that okay, the crusher house was not working properly. So these incidents, events, basically events would have also get now fed in to your AIML. Now your AIML is having an events log. So what they will see is, if at all on this time where my temperature was high, RPM was low, in my events log, do I see any event basically, which if something it has to say, if it says a downtime, then it will learn itself that, hey, listen, if I see such abnormality in any of these, something similar to this, there is going to be an downtime. And then also we can see, it can scan up and down also to see when was the last downtime again happened. And it can also predict that maybe possibility, if we are not fixing it, there can be another downtime in another 10, maybe 10 days or something like that. So now, as soon as we are able to do this sort of analysis and prediction, basically, we will immediately alert the how we will alert now. Today we are dependent on some gadgets only. The gadgets nothing but our monitors, the monitoring tools, the monitoring nothing but our dashboards. Dashboards, again, we use, there are multiple, I think Grafana, Kibana, if you guys are aware of them. So you guys can see Grafana is one of the most used diagnostic tools. Again, we use for all our graphical representations. And then we have Kibana as well for logging, and again for dashboarding. So for alert generation also. So this is kept on monitoring. This is easy to monitor, and it can send some notification to actually the site engineer. And it tells to the site engineer, hey, listen, looks like there is some issue and the motor needs a repair. Otherwise, there is a downtime. So now what will happen is, now the supervisor goes all the way to the motor, does the rewinding even before it goes bad, and that reduces our downtime. So this is one of the use case which I wanted to explain and wanted to see if I'm able to add all the elements, AI, ML, IoT, and the industries all together. Any questions in any part?
When we are using Raspberry Pi or PLC, how we know these protocols, sir?
Sorry, I didn't get your question.
Protocols we are getting here. We
Mhm.
have mentioned no communication protocols, MQTT.
Right.
Yeah, these
So,
protocols, how we
okay,
know when we are using Raspberry Pi or ESP32 module?
a nice question. I'll get a blank page. Okay, someplace. Okay, I'll try to use here. So what happens is, you have a Raspberry Pi. Small Raspberry Pi is there. Now, Raspberry Pi has multiple types of connectivity. It is anyways acting like it's a mini computer only, end of the day. So actually what happens is, your MQTT or RS485 is actually, these protocols are dependent on your edge device. So that means I have a turbine, and the turbine has only 3 pins, and one is your power pin, and the other one is 485 positive negative terminal. So what it does is, at every spin, it will give a pulse. Now this pulse has to be read. If you have seen the GPIOP pins, right, of our Raspberry Pi. So you are actually reading the pulse of them. So this is nothing but your RS485 protocol, because under some address, basically, one address will be there. In that, it will have this number pointed on the pulse, basically. So this is nothing but your RS485. And then there are some more smart devices who has an MQTT server inbuilt. They will have the topic. All you have to do is install MQTT listener and you log it to the same topic and it becomes your MQTT protocol. So it's all on your edge device, basically, in what protocol it is talking. And then you also become a client. Your Raspberry also becomes a client as soon as it has to send the data to someone. So now you can decide as per your environment that what kind of protocol do I want. For an example, if I have to send the data to, say, another device which is just sitting 10 feet away from your device, you would definitely not want an wireless or some communication protocol which can be compromised. You would want hardwired, and hardwired is Modbus 485. The reason is because 1 to 255 devices can send data in parallel in just one pair of wire, basically. So if you have black and red, almost 255 devices can send data on this on one pair of wire. But now if at all your Raspberry Pi has to talk to IoT hub or cloud, then you need either MQTT protocol, AMQP, and then you have one more HTTPS also. Now coming to your ESP32. ESP32 is a completely wireless through Wi-Fi API. Am I correct? You are talking about that one, right?
Yes, yes, both.
Yes. Yes. So this is nothing but it's actually exposing an API gateway for you. So you can use this API gateway to process some data, but end of the day, this guy has internet, so you can actually install your IoT Hub SDK inside this, and this talks to again your cloud. So it doesn't matter, what you choose. What matters is what is your edge device is about. And the more you go up in the hierarchy, the cost of the edge device increases. That means if you have an analog device, the cost is cheaper. You got electronics, little costlier. You go smart, even more costlier. You go for IoT enabled, it's further more costly. So this is a hierarchy basically which goes in.
Yes.
Any other question? Did I answer your question, sir?
Yes, sir. Yes, sir. Understood, sir.
Any other questions from anyone? Okay, yeah, that's all from my end today. So I hope I was able to, explain a bit of the industries, how it is working today with AI, ML, and try to give as simple example if I could. And there's a real-time example. You guys can actually look into this use case, which is there online available. It's from the Honeywell only. So we do it, but because of some IPs and all, I cannot get deep into it. But I could just do an overall touch base on most of the places possible. So again, by end, I just want to say that modeling is not the tough job. The tough job is to have the data and the right data, because your right data can actually screw your model. And when your model is screwed, you screw the whole process. So very important, the data and model goes hand in hand, and you need to make sure the data that you feed into your model is right. So my emphasis is on that basically. Yep. With that, I would like to open the phone for any other open questions or anything.
Sir, which type of AI program we can use for forecasting purpose under IoT environment?
It is very
For
subjective.
time series prediction.
Yes, sir. There is many things in this. Again, there is not a suitable AI modeling which is possible here, because uh, every why I'm saying is every equipment works in a very different way. Okay, so it's very difficult. So time series data, when we are actually looking into it, we need to see whether it is seasonal or non-seasonal. So again, the domain experts actually, they are the one who knows basically how the equipment is working, what is the characteristic of that equipment, then only they will be able to model it. So modeling just based on the data never gets the perfect thing. We need to understand the characteristic of the devices. So the characteristic of a device can basically explain that how the model has to be there.
But that device, it's not depends on time, no?
It
Maybe
depends.
character, yeah, depends. Yes,
It
yes,
depends.
depends.
It
No?
depends. It's very
Depends.
highly dependent.
Dependent,
Highly
yes.
dependent. Even calendar date also it depends.
Yeah, yeah.
Calendar second also it depends.
Yes,
So
depends.
we have seen cases where uh, see, for example, we think that AI ML has come now. During COVID time, some sort of smartness, or you can say some AI algorithms were still working with this power plants and all. And they are aware that at certain places, like certain of the states, the consumption of the electricity goes up very high during couple of vacations and all. And those algorithms were still running for few of the smaller equipments, not for all major because they can't take a risk of everything. And then during the COVID, this model was completely jeopardized. So this forecasting and all is something which we cannot say that this is right or wrong. So that is the reason we don't even recommend. So if you ask any data engineer or data scientist, they say that, what is the best suit modeling for this sort of time series or for sales or for this marketing, they will never, they can't tell you one answer basically. If they are telling one answer, then I'll say that they have only known that answer, and they have been using only that and trying to set that model to get the proper the predictive, basically the predictions and all. So I would say that open for everything. Sometimes even neural maps are also needed in the time series data. Basically, as I said, as soon as you integrate events, you will need neural maps. So many people start only with linear regressions and think that, okay, time series data linear regression will only work out, but actually maybe a part of it only. Once we run through one part, uh, the outcome of it might need to be put into another model of neurologic. I have seen models around 128 150 steps basically of different sometimes linear, some data, some output has come and that has been fed into another linear with another column of data, like this till 128. Still we have not got the exact, but we are close, that much we can say. But it takes a lot of time, sir. It takes a lot of time. With that, I can always
What
say that.
about
Mhm.
what about LSTM, sir? Long short-term memory for time series predictions.
So, okay, there are two types of, so this data, right? So what happens is, I'll use this page again. So we have this motor coming in, okay. So when the motor data is coming, when it, what I'll do is it directly reaches the cloud. I'll skip the in between the part. Once the cloud it reaches, you segregate this into two sets of data. We called it, which is cold, hot. Hot will always have somewhere 1 day, 1 day of time series. Cold is having till 20 years. Now, what happens is our advanced process management will have different trends, different trend charts. One of the trend chart would be at this point of time in the past 1 day, what is happening and what are the tasks. Basically, what happens is these motors and all, I'm just taking motor as an example because I'm thinking that the blowers are there. There's this air purifiers are there. So which blows to keep it cold. So these can be a day activity, every day-to-day activity. So these daily trends basically are to understand and manage whether these are done properly or these can be done daily basis. So and the one which is maintenance, like rewinding and all these things, maybe yearly basis. So these predictions will be coming from your cold store, which is not very important, not at given point of time needed every time, because this data, if you want to churn or if you want to process, takes a very heavy computation, and this heavy computation uh, can go till days. Till I have seen 10 days. We have set a query, and it takes almost 10 days to give us some results, basically. And then the question would be that 10 days, why? So we need to again come back to the time series data fundamentals. So time series data, basically what happens is when it, one of the major database which we use or which everyone is aware is Influx. Influx actually stores this time series data as shards, basically. So these shards can be somewhere of 1 day, sometimes of 1 month. It can vary like this. So to find out one specific data point from each of these shards, the clusters have to actually open each of these shards to get all the data points in one place and then process it. So it really takes a lot of time. And our queries will not be very simple because we won't be query only on one motor thing, because if we want to do some prediction, it will be the whole unit that can have 10 of motors, some heat exchangers, because we don't know where is the blockage in the pipelines or where is which wire is faulty, which is sending heavy current to multiple equipment. So we might have to do for multiple um, basically machineries here. So it takes almost till 10 days. So these predictions are used for only um, long predictive maintenances, basically, and which is short maintenance or immediate attention is needed is coming from your 1 day trends. This bifurcation happens is like whenever the data is coming, it actually one copy is always sent to the cold store, where one data lake, you might have heard about data lake, Azure data lake and all. So they keep on running on this and tries to pull out the trends, basically. And here is a very small uh, highly efficient module is working, AI, which is trying to see any abnormality in the 1 day of trend. So abnormality is only checked here, whereas here is your longer prediction. Is this was what you were asking the details, sir, or did I misunderstood you?
Yeah, it's a good concept you have given, sir. But there is in the deep learning models, there is LSTM libraries available. By using that thing, we can able to predict time series predictions.
Possible, sir.
Convolution neural
Possible,
networks
sir.
for images and LSTM for time series and other decision trees, forest, random forest. These are all for normal modeling applications. Even other feed-forward neural networks for modeling applications. Maybe we can use.
Correct, sir. So see, they are there. Even if you go and so what happens again when I say industries, people say that we go slow, but actually why we go slow is because we can only put the proven and working. So if something is working, if industries is doing something, and if it's working, that means it's tried and tested. Okay. Why I'm saying this is because one of the devices, one industry, I can say one device or one unit, uh, because I manage the data pipeline. 1 day data is almost 10 terabytes. So we accumulate 10 terabytes of data, which is unstructured data, basically. So which is coming in 1 day from one of the units like this. At this point of time, some numbers are there, but roughly somewhere 30K units is what we currently manage. So this is the amount of data we are talking. So we cannot, sometimes what happens is we cannot really wait that whether it worked or it didn't work for us. So for us, it is more of like it has to work. And if it has to work, as I said, your hot path. So if things are working here, is definitely is going to work here. So it's something like that. And we are so afraid to open this influx shards because if my influx chart stops working for any good reason, what will happen is this part will also stop. My all other data, all devices data will also go bad, because we are talking about 10 terabytes into 30K. So this is the actual use case, so which actually is happening on day to day basically. And I'm just talking about just one of the companies, and one company also a little bit part of it. So just imagine the amount of data that we churn out every day.
Yes. Thank you so much, sir. Thank you so much.
Thank you. Any other questions? Okay, I think I have already crossed my time limit. If no other questions, over to you, Musa. Thank you.
Any other questions? So thank you, Sagar, for the interactive session.
Thank you so much, ma'am. Thank you, Swati, ma'am.
So personally, I want to thank you for accepting our request and being with us as part of the resource person for this FDP on AI tools and techniques. We would like to have many more sessions like this for our students also in the coming future. So
Sure,
I hope all our participants have gained insights and knowledge, especially on the case study he has presented today. It was really a wonderful session. Thank you very much.
thank you, ma'am.
So
So now we have come to the final.
can we have the contact details for further collaboration, maybe further research? Because always the collaboration work, I am good in one part, Sar is good in one part. So this hybrid type of collaborations may leads to a good output, sir.
I'm always available on my personal time for sure. I can help it out. Yes, definitely, sir.
Any contact so that I can.
Yeah.
Share your details, sir.
Yes.
Yes, ma'am, please.
So good afternoon, everyone.
Okay, thank you so much,
Welcome
ma'am.
to
So I'll
the.
drop off. Thank you, ma'am.
Yeah, thank you, Sagar. Thank you.
Thank you.
Good afternoon, everyone. So and welcome to the last day of this FDP on AI tools, techniques, and applications. So I hope all of you have enjoyed all the sessions delivered by our esteemed speakers. So firstly, I just want to thank my heartfelt thanks to our management, Dr. Prabhakar sir, Sunita ma'am, our General Secretary and Director, for providing us the opportunity to organize this FDP. My sincere gratitude also goes to our CEO, Dr. Bhaskar Reddy sir, and our Principal, Dr. Arun Vikas Singh sir, and our Vice Principal, Dr. Manoj sir, for their constant support and guidance throughout this event. A special thanks to all our external and internal speakers for being a valuable part of this FDP. I would also like to acknowledge my organizing committee, Mr. Karthik, Mr. Girish, Mr. Vinay, Mr. Subramanya, Ms. Anupama, Ms. Preeti, Ms. Kavita ma'am, Mr. Yogesh, Mr. Raghavendra, Ms. Priya, and Manju for their incredible support in making this FDP a success. So lastly, a big thank to all the participants for your active engagement and interaction during the sessions. I hope you all have gained valuable insights and takeaways from this FDP. The recordings of all the sessions we have uploaded in the YouTube. So feel free to revisit them at any point of time. So once again, I want to extend my heartfelt thanks to all the external speakers as well as our internal speakers. So for being with us all the 5 days, for accepting and being a part of resource persons for this FDP. So thank you once again for being part of this FDP. I wish everyone have gained some insights and knowledge about AI tools, techniques, and where and all you can use these tools. So I wish everyone a happy Ganesha Chaturthi. So thank you once again. If you have any, we'll be sharing you the feedback link shortly. So you can fill the feedback and these certificates will be sent over to the mail. So if you have any questions, you can communicate to us at any point of time. So we'll be sharing the resource person numbers, whomever you have asked. So thank you once again.
Thank you, ma'am.
So if you want to share any feedback on our FDP, you can feel free to share. We want some of the participants, you can share the feedback. You can unmute and you can share the feedback.
Thank you very much, ma'am, for giving the opportunity. My personal thanks to Dr. Manoj, sir. He's in touch with me and give an opportunity to attend this useful workshop. Definitely, whenever we are attending this type of workshops, our knowledge will be enhanced. In that way, I'm thankful to Gopalan Academy and also to Dr. Manoj, sir. Maybe I may express my gratitude if you'd have give the resource person contact details. Just only be in touch with them for further collaborations, sharing knowledge, something like that. How we can get, ma'am, details?
So we'll share you through personally through your WhatsApp.
Okay, maybe Dr. Manoj sir is responding immediately whenever I'm sending message. Thank you very much, sir.
Sir, good afternoon. This is Manoj here.
Yes.
Yeah, definitely. Thanks. Thanks for joining and having a very interactive sessions. Surely, sir, as per your request, I will share you. Anyway, I have a personal number. I'm in contact with you. So surely, definitely, I will share all the contact details with you, sir.
Yes, sir. I'm working as a senior lecturer in the University of Technology and Applied Sciences, Oman, sir, near Muscat.
Yes, sir. Yeah, I know. We connected a couple of times for some of the sessions as well, I think.
Yes, I keep on
Sure,
attending.
surely, sir. I will share the contact details.
Thank you so much, sir. So nice of you, sir.
Thank you. Okay, good afternoon. So once again, I would like to thank all the participants who are attended all the 5 days of our FDP program. And again, I want to extend my sincere thanks to all my external speakers who really accepted during their weekdays of the schedule. So the first day we have Christopher who joined from Canada. I'd like to thank Christopher Alexander who shared his knowledge with all our participants. Then we had Abrar Syed, Abrar, who has been from Singapore. I think he has shared regarding the Gen AI and a few more applications. And we have Mr. Prashant Akija from SAP Labs. So thanks, Prashant, for joining our FDP and sharing your thoughts and knowledge with all our faculty fraternity. And today we have Mr. Sagar Datta. So I would like to sincerely extend my thanks to Sagar. Actually, he was supposed to join by 10 o'clock here because of his unavoidable meeting schedule. He was joined at 11 o'clock. So I would like to thank all the external speakers. And also I should extend my thanks to all the internal speakers as well, starting with Professor Karthik, Professor Girish, Dr. Swati, and of course myself. So since we got a very good response, and we'll be planning few more activities in the same lines. Maybe we may plan offline as well. So hope we'll connect through FDP once again and have a good connectivity through other things. Okay, thank you very much for joining our FDP. And as Dr. Swati has mentioned, we'll share you the feedback link. Please give the genuine feedback so that it will really help us to improve for our next activities. And one more thing, just make a note while filling the feedback, make sure your name, organization name will be very appropriate, because same thing will be seen in the certificate as well. Okay, so thanks for joining. Thank you very much.